Well, welcome back. It's a snowy day in Colorado here on March the 31st, 13th rather, 2021. Glad to be back with you. And again, I don't know why I've got this ruddy looking image. I don't look this way, but I hope it works for you anyway. We're going to take a look at various types of disasters, beginning with Korean Airlines. And I hope you find this as interesting as I do. So let's get going. So as I ended last time, this is starting episode 11, and I was completely fascinated that Korean Airlines was crashing at 17 times international norms, and it went on for 4 years. What could make this happen for such a long time? Even a child would say, "What in the world are you thinking, folks? This is crazy." And we're not talking about small jets, we're talking about big jets, 747s, killing thousands of people. It got so bad, the president of Korea refused to fly on Korean Airlines. And so, what was the basic error they made that let this happen for so long? What did they assume was the case? You think they assumed technical abilities or social context? I can tell you, they thought it was technical. And what they did is what you would obviously think to do. They put pilots in simulators. This happens to be one of United's 747 simulators in Denver. And by the way, I had the pleasure of flying a 767 simulator at United last year. My my daughter's boyfriend happens to be in charge of simulation training for United, and so I spent a day practicing landing a 767, which was interesting, fun thing, and he didn't give me any hard problems. That's pretty easy. Anyway, the Koreans had, as you would expect, instructors evaluating and watching them, and under the instructor's watchful eye, they did passably well. So Boeing finally put observers in Korean Airlines cockpits to see what in the world was going on, and they were shocked. What they saw was that first officers ignored the captain's errors, tuning out, when they absolutely knew that safe flight requires two pilots, one flying and one monitoring, constantly cross-checking each other. Now, here's what I know for sure. Boeing or Airbus will not allow a flight crew to take an airplane out of their factory home until they've tested them in simulators and then flown them with a pilot watching. And what they're looking for is not just basic piloting skills, they're looking for cooperation in the cockpit, because every pilot is trained to understand that safe flying over time requires two pilots working together, one flying the airplane and one monitoring the instruments and constantly cross-checking each other. So what could, this is so basic, what could make them lose track of something as fundamental as this? Well, so what happened is they turned out that the Koreans had imported Korean Confucianism into their cockpits, which demands complete deference to elders. It's a very extreme form of Confucianism. And I wouldn't believe this except I saw it with my own eyes. For some months, many years ago, I housed two Korean men who were studying at the university. English is a second language. And I watched the older one just berate and attack the younger one mercilessly, and he took it. I've seen this up close and firsthand. What's the cause of all these crashes, all these deaths? Demands for deference overrode their judgment and training. Here's what's most interesting, the takeaway here, a really important takeaway. Once you diagnose the problem to be social context, the remedy is often very straightforward. In this case, Boeing said, you can only allow English to be spoken in the cockpit, because if you allow them to speak Korean, they'll go back into their social context. And I think most of the pilots for these big jets can speak some English anyway, because all airline flight communications internationally are in English. And they also reinforced the teamwork in the flight simulators with what's called crew resource management. To this day, airlines train this and use this. Some of the most incredible survival of crashes ever recorded have all happened because the crew was working as a team. So within months, they went back to safe flight. So I mentioned these examples earlier, said I would put more meat on the bones. This is the deadliest airline crash in history. And Boeing jets were diverted by a bomb scare in Madrid to a tiny airport on Tenerife Island. KLM's most famous pilot, Captain Jacob Van Zanten, was piloting a 747, and he had the plane fueled. He wanted to get home for an event for his daughter, and he taxied the 747 onto the runway in heavy fog. The airport was not really suited to these big jets. So what happened is they were asked for a takeoff clearance, as normal procedure would be. A garbled message came back, and the captain spooled the engines up for takeoff. The first officer said, "Captain, I did not hear a takeoff clearance in that message." And the esteemed captain glared at the junior officer, embarrassing him. When a second garbled message came through, the captain spooled up again. This time, the first officer remained silent. The plane collided with a Pan Am 747 parked on the runway and killing 583 people. Same thing. This is a social problem. Demands for deference overrode judgment and training. These were experienced crew. They knew better and didn't do it. This is the second biggest train accident in Tokyo history. Trains are a big deal in Tokyo. Half the population of Japan rides a train to work on a normal day, and the trains are very rigorous in schedule. I've been on a Japanese train where they apologized for this was a Shinkansen, an inner city train. They apologized for it leaving half an hour late. Half a minute late. I misspoke. So in this case, the driver overshot the platform, and he didn't want to get this so-called rehabilitation that's very demeaning. So he negotiated with the conductor who's on the other end of the train to report a smaller overrun, because there's a distance amount that if you go under that, it's not a big deal. Over that, you have to get this so-called rehabilitation. This included things like spending a month scrubbing tracks with a toothbrush. So now the conductor finally agreed, and when he started now, the train's late. Now, most trains have transfers in Japan. It's a very extensive rail system. We're talking subways kind of thing, and above ground subways mostly. And so if the transfers are often 1 minute, and the trains run on time, and you can make these. If you miss a transfer time, that also gets a rehabilitation. So there were posted speed limits. He went over them to avoid this punishment, and derailed, killed 106 passengers and injuring 562 others. Just like I showed you with the example of Hubble, the behavior was driven by a desire to avoid punishment, a social context failure. This one might surprise you. Like most of you, I watched the explosion of reactor number 1, that's Daiichi at Fukushima, with shock. And I watched TEPCO, and very predictably, the electric power company that ran the reactor, they first blamed the earthquake and then the tsunami. I knew better. It's social context. I just waited. The government convened a panel of experts from Tokyo University, Todai. That's kind of like Stanford, Yale, and MIT all rolled into one. And a good friend of mine is a professor there, Jun Nishimura. He put me in touch with the chairman. Chairman and I had email exchanges. He said the disaster was man-made and avoidable, including Japanese insularity. It is a very insular, homophobic culture. They ignored foreign experts' recommendations and blind obedience to authority. So again, blind obedience to authority overrode good judgment. They knew that they should not have had those generators down close to the sea. They had recommendations to take care of it. When the supervisor said, no, we're not doing it, they just let it go. So again, social cause. People ask me for a recent case, and this is a doozy. the 737 MAX. I think at the peak, over 400 planes were grounded. There were so many planes on the ground, there was no room for them in airports anymore. So you see, they had them in parking lots with cars. By the way, it's quite a complicated thing to restore one of these airplanes to flight after sitting idle a long time. You got to deal with the tires, the engines, many things about them. They're not made to sit idle. So what happened? Well, Airbus announced they're going to build the 321 new engine option, or NEO, with 15% less fuel consumption. And the Boeing CEO, Dennis Muilenburg, who thankfully is gone now. I don't know why he did this. He's an experienced engineer, longtime Boeing employee, apparently. And he said, don't worry about this. Our customers will always buy from us, citing, if it's not Boeing, we're not going. 2 years later, American Airlines called him and said 15% improvement is too large to ignore. By the way, fuel is the biggest expense in an airline. So he said, our next order is going to include 200 321 NEOs. Boeing responded with, if we re-engine the 737, will you change your order to buy 100 of those and we'll get the same efficiency? American said, sure, if no simulator retraining is required and you meet the schedule. So why is this important? Well, the simulator training is expensive. The simulator is expensive to operate. The flight crew, it gets tied up. They got to go someplace and spend, I'd say, at least a day on a simulator for any kind of recertification, and staff to manage the whole thing, and they lose days working, and on and on and on. So the airlines have what's called a type rating. If an airplane is the same type, they don't have to go to a simulator to fly it. And so, for example, the 757 and 767, even though they're rather different airplanes, have the same type rating, and a pilot who can fly one can fly the other. They demanded that the 737 MAX be considered a 737 type, and therefore no simulator retraining, and they had to meet the 2-year schedule. The 737 is an unusual airplane. It's my least favorite airplane of the large jets. It was designed in the 60s for short hauls and small airports. And in these days, jetways weren't common, especially at small airports. So they actually had their own ladder, like a lot of business jets have. And to make the baggage handling easier, it sat very close to the ground. I think it's like 3 feet off the ground, because in those days, these conveyor belts for taking baggage on and off were not so common at small airports. This is unusual too. It uses cables and hydraulics rather than fly-by-wire, which almost every modern airplane uses. So what's that mean? When you're piloting the airplane, you're actually running resistors and other electronic devices that turn motors on the surfaces of the airplane. And these have feedback as though you're flying regularly. But many of the most modern airplanes have the checklist, even emergency checklists come up on screens, because now they've got the newest airplanes have big digital screens rather than paper checklists, which are in a book you have to go read. How do you make an airplane more efficient? Well, the most important single thing you can do is make the fan bigger. So for a long time, jet engines have been what's called high bypass. What that means is there's a turbine in here with very high pressure fuel being burned, going through multiple stages, and it turns this big fan in the front that acts a bit like a propeller. That's why they're quieter and more powerful and more economical. So the second thing they do is they increase the pressure in the turbine, but that wasn't an issue in this case. The problem is this is what the original 737 looked like, and you can see how close to the ground the wheels are, and the engines it was originally designed to have, which are regular turbojet engines, not these high bypass types. So the constraints of having a bigger fan and the low to the ground design caused many improper engineering decisions. New engines had to be mounted higher up and further forward. So you can see how that would increase the tipping moment. And so what they worried about was under high power, it would tip the nose up. That would cause the plane to stall and fall. and particularly during takeoff where you're using your highest power setting. So they installed a thing called the MCAS, Maneuvering Characteristics Augmentation System. This is common on military jets. Military jets do a lot of flying by this kind of instrument, but on commercial jets, since they use the angle of attack sensor, on commercial jets, the angle of attack sensor is not used for the primary flying. Other things are like the airspeed and the angle of attack and so forth. Jets have these, and what they're useful for is you can spot turbulence and the like because it'll affect this angle of attack sensor. So it's kind of on a commercial jet, additional information for the pilot. With this system they put in, what it would do is take the horizontal stabilizer, that's this big thing here. You can sort of see the places where it turns when it moves, and it would turn this big stabilizer fin and push the nose down. Well, the controls that the pilot has access to is this little tiny elevator on the back, this little fin on the back. So this is a very big thing, and it's insane to think you're going to put a single sensor, especially one like this, that's very prone to damage, bird strikes, ground handling. It's a very vulnerable sensor to make a single sensor. Why would they do that? Well, they knew that if they changed the design enough to put in redundant dual sensors, that would give away what they're doing with it. That would make the FAA change the type rating, and that would make the simulation. So here's where it gets really fantastic. The early version of this, they put in their operator's manual that this system existed, and then they took it out. So even the airlines didn't know this was even there. So this is the yoke. This is how you run that little elevator on the bottom and the ailerons to turn. And normally Boeing's claim to fame is that the pilots would be able to always control the airplane rather than Airbus, which is much more computer controlled. This is the wheel. All airplanes have something like this. Even when I've flown single engine small airplanes, you turn this wheel by hand, but this will spin automatically as the plane trims itself. So in normal flight without the MCAS, there's sensors on the airplane. And so, for example, as you burn fuel, the plane will change its center of gravity. So it will compensate. What you want is the plane to be neutral. You want it to fly level without having pressure on the yoke because it's easier for the pilot and it's more economical. So they're flying along and suddenly this thing starts spinning. The nose starts going down. They have no idea what's happening. They're trying to correct with the elevators, with all the strength they've got. It's not good enough. The wheel's spinning rapidly. There's a little handle here, but it's hard to turn and takes lots of turns to override this MCAS. Rather than simulator time, they propose an hour on an iPad as enough training for new pilots. This is all nuts, okay? And to meet the schedule they promised, the development was rushed at twice the normal pace. This means drawings weren't right, parts weren't right, so forth and so on. How could an experienced aerospace company like Boeing have such a mess? Well, it's a massive case, I believe, of confirmation bias. I showed you this before with the case of the Hubble mirror, where the human mind wants to believe something that's not true and convinces itself by looking at very limited data. But the root cause was the social context of panicking Boeing management. Blind obedience to authority. I'm guessing that good technical people said, look, we're not doing this. And management said, fine, you're fired. So close out this section. We are so tribal that excuse me, social context fields generated by our behaviors powerfully affect others' behaviors. These social contexts address two deep human needs. I think the tribalism, I'm always looking for the deepest level. I think the tribalism is fed by our need to feel valued and loved and our need to feel included. And I think it's quite clear that the group you affiliate with has to do this for you. And social contexts cause failures when people ignore them. For example, blind obedience to authority caused the Fukushima Daiichi explosion, the Challenger explosion, and the 737 MAX crashes. Avoiding criticism hid the Hubble mirror flaw and caused the Tokyo train crash. Inappropriate deference to authority caused the Tenerife Island crash and the Korean Airlines crashes. Now, I don't know if these are the only three social context failure modes. There may be others, but these three emerge from the examples I chose because I think they're so easy to understand and well known to everybody. Go ahead to a little quiz I do in the workshop. So in a normal workshop, I do about a slide a minute. So we're about with 95 minutes in now, and with a 10-minute break, we're about 100 minutes in. And I know what people like to do is talk to each other. So I gave them this little exercise to do and write in their workbooks. And a friend of mine said a long time ago, there are two things that matter most: your character and your competence. I align character with the 4D system, and these are the 8 behaviors. So ask them to address these, just circling things. Then your competencies, things you do efficiently and successfully, your self-management, interpersonal management, technical expertise, hobbies like travel, and your general knowledge of things. And then I have them, and we did workshops in person in 4-person huddles. With the Zoom workshops, we organized them into 4-person groups. I found by accident this is by far and away the most effective sharing modality. And by facing each other, either with Zoom or in person, you energize mirror neurons and empathy, and have them read what they wrote in their workbooks. And verbally, talked about this earlier, red card people telling a lengthy story. And I like to have them give a little appreciation when each person shares. It's just honoring each person's truth. And also, when I'm doing workshops in foreign languages, I can tell how progress is going by watching the groups do this. And I used to have people, as soon as they finished working with their group, return to their seats. But now I tell them, if you finish the exercise, just keep talking about whatever you like. People enjoy this. They talk about themselves or sports or whatever. And then when all the groups are finished, we sit down. Very many years optimizing this. And so we're going to next go into episode 12 and take a deeper look at social context. Hope you found this fun. Please join my YouTube thing by subscribing. It'll help other people find the channel if you like this. And see you next time. Thank you very much. Be safe and be well.